All right, guys, this is section 6.3 on our kind of intro to exponent laws as we move forward. Um, we've heard recently at meetings that students are really missing their teachers, so I just took a selfie and threw a picture in there. As you can tell, I haven't had a haircut or a shave in quite some time. But that's me. That's me. So this whole section's on exponent laws and basically what to do in these different situations right here. So, as you guys probably know, when you have something that's squared, that's going to be b times b. B to the power of 2 is b times b. So, if they ask you for expanded form, that's b times b. All right. If it's multiplied by b to the power of 4, well, that's going to be 4 of them. B times b times b times b. If you combine those together, I'm not liking that red pen right now. I'm going to switch to black. Let's see what that looks like. That looks better. You can see that there are 1, 2, 3, 4, 5, 6 of them. So that ends up being a total of b to the power of 6. Now, if you look at the 2 and the 4 that came b to the power of 6, that's essentially the exponent law. When you're multiplying like bases, what do you do with the exponents? You add the exponents. All right. Likewise here, b to the power of 6 is b times b times b times b times b times b. Is that 6? 1, 2, 3, 4, 5, 6. Yep. And b to the power of -3, I don't know if you guys know this or not, but a negative exponent means it goes underneath. So -3 means b times b times b instead of up top. It's still to the power of 3, but it's underneath. It's like 1 over it, all right? So what happens here is we've got the b's on the top and bottom cancel each other out. So cancel, 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 cancel. What did we end up with? B to the power, I don't know why I made that so big, b to the power of 3. Again, it followed that rule. 6 plus -3 is 3. You're just adding the exponents. I'm going to do one more like this with expanded form in case it's asked of you. B to the power of -6 means I got 6 b's on the bottom. B times b times b times b times b times b. Is that 6? 1, 2, 3, 4, 5, 6. Yep. And then 8 of them on the top. B to the power of 8. 1, 2, 3, 4, 5, 6, 7, and 8. Cancel, 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 cancel. How many am I left with? 2 of them. Equals b to the power of 2. Again, it follows that -6 plus 8 is equal to 2. You're just adding those exponents. That's why these exponent laws work. The power of a power, the same sort of thing. So b to the power of 3, if I expand that, it's going to be b times b times b. And then squared means that I have to have 2 of those sets. So b times b times b times b times b times b. How many of them are there now? 1, 2, 3, 4, 5, 6. It equals b to the power of 6. How did we get that 6? 3 times 2. You multiply it when it's outside the brackets like that. Let's take a look at this one. It's b to the power of -3 to the power of 4. So it's 1 over 1, 2, 3 to the power of 4. All right. So I got to have 4 sets like that. I might run out of room here. So 1 over b times b times b times 1 over b times b times b times 1 over b times b times b. I need one more set to make my 4. There we go. So I've got just 1 on the top. How many b's on the bottom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's b to the power of 12. Now, 1 over b to the power of 12 can also be written properly as b to the power of -12. Remember that -12, put it on the bottom there. The negative puts it on the bottom. Last one I'm going to show you here is b to the power of 4 to the power of -1. So let's try that out. So I got b times b times b times b. There's my b to the power of 4, and it's to the power of negative 1, which just puts it all over 1, all under 1 rather. B times b times b times b. So that's 1 over b to the power of 4. Just like with the 12, it becomes b to the power of negative 4. All of these exponents, all of these answers could have been gotten much quicker than this. If you're thinking, holy smokes, that's a lot of b's to write out. That's not the point of this. It's to show you where these rules come from. Really, what I want you to learn is that 3 times 2 got us the 6. Negative 3 times 4 gets you the negative 12. 4 times negative 1 gives you the negative 4. That's what we're supposed to be learning here. Let's move on then. Last skill is dividing powers, and it looks like I dropped the ball here a little bit. These should be superscript, so it should be b to the power of 7 divided by b to the power of 2. So let's make it just like that. 7 b's, 1, 2, 3, 4, 5, 6, and 7, divided by or over b to the power of 2, which is b times b. Cancel, cancel. With those two, how many do I have left? 1, 2, 3, 4, 5 equals b to the power of 5. How do we get that? How could you get that quick? 7 divided by 2, 7 minus 2 gets you that exponent 5. Just like here with this one, again, I missed the exponent, so it's b to the power of 2 divided by b to the power of 3. So if I expand that out, I've got 2 b's on top and 3 b's on the bottom. Cancel, 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 cancel. So on the top, you'd think, well, is that a 0 on top? No, it's going to be a 1 if you cancel those out. And on the bottom, I've just got one of these b's left. So 1 over b to the power of 1, you could say, or b to the power of negative 1. Again, we could have gotten that without all this expansion just by thinking 2 minus 3 gives you negative 1. Last one I'm going to show you here. B to the power of 3 over b to the power of 7. I don't know why I chose one with such a large exponent. That's going to be a pain to write out, but that's okay. Put my line here. I need 3 on the top. That part's easy. 7 on the bottom. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. There we go. Cancel, cancel, cancel. With 3 b's on the bottom, I got 4 left. So it's 1 over b to the power of 4, or b to the power of negative 4. Again, what you're supposed to learn is that the 3 minus 7, you subtract the exponents when you're going, when you're finding that final exponent. All that stuff in the middle, if you remember that, can be skipped. So again, the base can be anything. Why don't we call them a's now instead? So a to the power of, I guess we're going to call them x's and y's. A to the power of x times a to the power of y is equal to a to the power of x plus y. For example, a to the power of 3. Now let's make a big one that we could never really would do. That's supposed to be a times in there. Hopefully you can see that. A to the power of 3 times a to the power 11 is equal to a to the power of 14. We would never want to write that all out. So that's for multiplication. For the ones with the brackets, you multiply them together, so it's a to the power of xy, or x times y. For example, a to the power of, well, let's use 3 and 11 again. Why not? A to the power of 3 to the power of 11 is equal to a to the power of 33. I'd never want to write that one out. 3 times 11 is 33. And then finally, a to the power of x divided by a to the power of y is equal to a to the power of x minus y. For example, let's go a to the power of 15 divided by a to the power of 12 is going to be equal to a to the power of 3. 15 minus 12 is 3. All right, and then you can skip all that expansion stuff. Just some more examples, and I don't like the way that that showed up for some reason. I'm just going to go ahead and move that around a little bit, if I can. So, just need to reattach my keyboard here. So I've got some examples just to work out with you. And I just need to put them in the right spots. There we go. There we go. There we go. Let's go back to present. And 5 to the power of 4 times 5 to the power of negative 2. And back to red is equal to 5 to the power of 2. We're multiplying exponents, so you just add them together. 5 plus negative 2 is positive 2. We don't need to evaluate these exponents. Negative 6 to the power of 2 divided by negative 6 to the power of negative 1. We subtract those exponents. Now that one's going to be kind of tricky to do. That means you got to take the 2 and subtract a negative 1, which becomes 6 to the power of 3. Down here, I've got m to the power of 5 to the power of negative 3. You multiply those exponents, becomes negative 15. And then this next one, the last one, is going to take a few steps because the top, a to the power of 2 times a to the power of negative 5 is going to become a to the power of negative 3. But then it's divided by the bottom, a to the power of negative 2 to the power of 3, which becomes a to the power of negative 6. That didn't turn out quite right. So these two made that exponent negative 6. The 2 and the negative 5 became negative 3. Now I got to divide them. Now that can be a bit of a pain because you got to subtract the exponents. So that's going to be negative 3 minus negative 6, which is negative 3 plus 6, which is positive 3. So my end result is a to the power of 3. And that's where these go to, everybody. The last thing I'm going to do is solve a problem with you. The number of hybrid cars sold can be modeled by the formula S equals 199,148 times 2.39 to the power of n, where n is the number of years since 2020. A says evaluate for n equals 0. What does that mean? Well, that's initially, that's going to be how many cars were sold in 2020. So I'm just going to put that cars in 2020. And we can evaluate that. If we put a 0 in for n, we go 199,148, 2.39 to the power of 0. 0 is going to actually eliminate this term because anything to the power of 0 is equal to 1. So it's going to equal 199,148, and that's going to be the answer. Again, I don't like my red pen, so I'm going to switch it to black. There we go. How many were sold in 2019? Well, that's weird because that goes back a year. So what you're going to do there is put in 199,148, 2.39 again, to the power of negative 1 because we're back a year. And I'm going to punch that into my calculator. I'm going to go 199,148 times bracket 2.39 bracket to the power of negative 1. And it's going to give me less cars. It's going to give me 83325. And I left off the decimal places because we're looking at a number of cars. In 2025, there's going to be a whole bunch. I don't know how accurate this model was. I stole this equation out of the textbook. 2.39 to the power of, that's 5 years later, 199,148 times bracket 2.39 bracket power of 5 equals 155,29785. Lots and lots and lots more. So the problem solving mostly is just using your calculator to evaluate exponents. These are the questions I want you guys to work on. Can I write on this? Yeah, I can. So I want you to do Number 1, 2, 3, 4, 5, 6, 7, 8. There's a couple more pages of questions, but I think that's plenty, guys. And they should be quick. I mean, you might think, well, that's a lot of questions, but like, look at these questions. 2 to the power of 3 times 2 to the power of 4. Well, that's 2 to the power of 7. Done. C to the power of 5 times c to the power of 4. Well, that's c to the power of 9. Right? So they're not meant to take you very much time. I hope that you guys can cut through this really, really quickly. And then you may have to think at the end with the word problem, which there's only one of them, so it shouldn't take much at all. If there's any of these that stump you, then please just email me and I'll walk you through any one or whichever ones you guys are stuck on, okay? Let me see, do I have another slide here? Yeah. It's on page 362 and 363, number 1 to 8. Attach a picture of your work and hand it in. And good luck with it, guys. I think that's it for me for now. And yeah, good luck. Keep the emails coming. I'm happy to help.